All right, so I'm Miss Petrossi. If you guys have any questions or need any help with chemistry, which I'm sure you do, I will have tutoring after school Friday. And if you would like some more tutoring, come see me next Monday or Tuesday. If you can't, stay on Friday. You can also send me an email. This is how you spell my last name. I'm the only Petrossi in the county. And also, I'm sure you have some friends who I teach who can help you as well. And yeah, don't be afraid to come talk to me or any of the other chemistry teachers, because this is a review for midterm. This is a review of Unit 1. I'm not going to cover every single question because you are going to get the answer key. This is not for a grade. This is not for extra credit or anything. This is you to look over to remind yourself of what you need for the midterm exam. Okay, so let's get started. We have 4 models of the atom here. And they're in order from not first, but the beginning to the end, the beginning to what we currently have. And we have some questions to go over each model. I'm just going to run through it real fast. All right, A says, which model shows electrons circling? There's only one model that shows circles, right? Bohr's model. So, circling nucleus in orbits at different energy levels. That's these circles. But has limitations in improbable location of electrons. Bohr knew there was something involving energy and electrons, but he didn't know exactly where the electrons were. This was his prediction. This is one we like to draw the most because it's the easiest one to draw. B, which model describes an atom having a dense positive nucleus? Dense, meaning very thick, like you can't really go through it easily. Positive nucleus. There's only one with a plus sign in the center. Nucleus is in the middle. That's Rutherford. That's surrounded by mostly empty space. So remember that marble experiment we did where we rolled the marbles with the shapes. Okay, C says, how does the current model show improvement over the previous models of the atom? So current model is what we currently have. It shows these little bubbles, like these little balloon things. So it shows exact areas where electrons are located, and meaning the S, P, D, F orbitals. Don't forget about SPDF on your periodic table. You need it with electron configuration. D, which model describes an atom as a positive sphere with electrons distributed throughout? So there's only one that shows electrons throughout the whole atom. And that could be like these little things. Like throughout, like in multiple places. So that's J.J. Thomson. He described 2 big differences between Thomson and Rutherford's model. So just looking at them, does Thomson have a center nucleus? Thomson does not, but Rutherford does. You just need to put that in 2 words. Also, Thomson discovered the electrons. Rutherford discovered that there's a positive nucleus. And that he knew the electrons were around it. Okay. Two, use the table to answer the following question. Which atoms in the table are the same element? Same element, that's your key word there. And with what reasoning? So you need to explain this. So same element. If you ever see something saying same element, you're thinking about protons. Same number of protons, the same element. So it's atom 1 and atom 2 because it says which atoms. Same Proton identifies, whoa. Proton identifies the element. Proton is the identity of the element. Okay, 3 says, answer the following questions about atomic structure. The atomic number of an element is based on which subatomic particle? Subatomic particle. So it's either proton, neutron, or electron. Atomic number goes with proton. Atomic number equals proton number. Which element has atomic number 42? You look on your periodic table, find 42. I'm not even going to try to say that element, but I know the symbol's MO. In a neutral atom, the number, so neutral, that's how you see it on the periodic table, the number of protons is equal to the number of electrons. So a neutron, proton number equals electron number, which also equals the atomic number. That's the top number you guys see here on your periodic table on the top left. All right, nuclear fusion. In nuclear fusion, two lighter, meaning weight, they are very light elements, combine, they fuse together, think fusion dance from Dragon Ball Z, to form if two light things combine, they're going to form something heavier, weighing more heavily. So think about this. These are two light elements. They combine together to form something heavier. All right, B, what is the product of the following reaction? So with these, there's no magic to it. Cut it in half, and you're going to add the top two numbers, 24 plus 4. You get 28. And then add the bottom two numbers, 12 plus 2. And you should get 14. Now, I need the symbol. So am I going to look at the top or the bottom? It won't let me change colors. I want to look at the bottom. So atomic number is identity of the atom. Proton number is identity of the atom. The mass is always the bigger number. The atomic number is always smaller than the mass. So I need to look on my periodic table, find number 14, which is Si for silicon. Why is that not going away? All right, so you should be able to do the other two. And again, if you need more help with that, you need to come see a teacher. 5, you should be able to fill this in. The answers are on your answer key. Again, it's not a grade. This is for you to make sure you understand this for the midterm, which is a grade. And if you need help with any of that, you have to see a teacher. Now, one thing I will help you with is F. I'll start with F. Because, guys, these aren't answer choices. You're having to actually answer every single question. Every letter is a question. Okay. What would be the isotopic notation? Naming an isotope, basically. So isotopic notation, isotopic name for an atom with 11 protons. I want to focus on 11. Find atomic number 11 on your periodic table. 11 is sodium. So I'm going to do the isotopic notation first. So first you write the symbol, Na. The bottom number on the bottom left is going to be the atomic number. The top number I'm going to put up here is going to be the mass. To get the mass, you do proton plus neutron. So 11 plus 12. So the bigger number is always the mass, the smaller number is always atomic number. And then right here's the symbol. Do not flip those numbers. That is how you will get an answer incorrect. That should be an easy one to get correct. Okay, so for the isotopic name, you're going to write the element's name, sodium, hyphen or dash, the mass. So element's name, dash, the mass. G says examine the following isotopic notation, so they give us that. And I already kind of helped you with that up here, so hopefully you can label these properly. How many protons does this isotope contain? Atomic number is proton number. How many neutrons does isotope contain? So every year people forget this because you have to memorize this to get number of neutrons. Mass minus proton. You are not going to be given that on the test. Neutron is mass minus proton. So you're going to do 210 minus 90. If you write 90 here or 210 here, that's the wrong answer. So 210 minus 90, 120. All right, how many neutrons are in an atom of neon 21? So here we got to think about it a little bit more. You do have to use your periodic table. And remember, guys, you can write all over it, write on your scratch paper. So neon 21, what is 21? 21 is the mass. And it wants number of neutrons. Neutrons is mass minus proton. You need to find neon. Neon is number 10, so 21 minus 10 is 11. Just keep writing it over and over again. Mass minus proton. 7, which is the correct symbol for the atom with 42 protons and 49 neutrons? Ew. Okay, so easy way to knock out 2 answers from what I see. Find number 42 on your periodic table, because remember, proton number is atomic number. 42, the symbol is MO. And right away, I know it's not A or B. Now here's the hard part. What goes at the bottom, what goes at the top with this isotope notation? 42 goes at the bottom. And if you look, there's only one with 42 at the bottom. Now, if it's not like that, to find the mass number, proton plus neutron. Do you see that, like, they're flipped around? Finding neutron versus finding mass is flipped around. So you're going to do 42 plus 49, and you get 91. So I want 42 on the bottom, 91 on the top. Answer C. Okay. People miss this, and it makes me honestly want to cry when people miss this. Please don't miss a question like this. Which of the following proton and neutron combinations, so P and N stand for proton-neutron, makes up the nucleus of helium? Find helium on your periodic table. The number of protons helium has is 2. The number of neutrons, it's not 4. It's going to be the mass minus the proton. So it's 2. So you're looking for something that has 2 protons, 2 neutrons. Because you're looking at something that represents the nucleus. Protons and neutrons live inside the nucleus. Ooh, fun stuff. Okay, this one looks scary, but there's easy ways around the scariness. So it says, group of students given the following information about 3 isotopes of uranium and tasked to estimate the average atomic mass. So you might think you might have to do some math, but we can actually figure this out without having to do math. So here's 3 isotopes: isotope 1, isotope 2, isotope 3. That's the mass for each of them, but this is the actual mass for each that you want to focus on. Okay, so it says estimate the average atomic mass. You want to look at percent abundance. Abundance means how often do you find it? How much is it there? So which one do you see the most of? Which one has the bigger percent? So, of uranium, most of it is made of uranium-235. And meaning makes up most of uranium atoms in the world or universe. Like most of if you were to pick up a piece of uranium or a little uranium atom, most likely 82.4% of the time it's going to be uranium-235. So student 1, so A says student 1, the average atomic mass is greater than 239 because it is the highest mass. No, we're not looking at highest mass. Student 2, the average atomic mass is greater than 238 because it is between the lowest and highest. No, that has never been talked about. You're not looking for between. Student 3, the average atomic mass is close to 235 because it is the highest abundance. That's your keyword there. Meaning biggest percent. $235. Now let's look at D, because I bet you if this were a question on the midterm, half of you would pick D. And please don't do that. Student 4, the average atomic mass is close to 237 because it is the average of all 3 masses. When we do that, we're not getting average like in math. We're trying to use percent and mass to find which one we see the most. So please don't get tricked by that. All right. 10, use the information table to answer the following question. What is the average atomic mass of element X? Okay, so again, this wants you to do math, but you don't necessarily have to do math for this based on these answer choices. Which one do you see the most of? Which one has the biggest percent? The 92.2%. And what mass do you see? This is very close to 28, right? And that's saying it's X28, like isotope 28. Doesn't matter what the element is. There's only one answer choice close to 28. Now, I can do the math and show you that in case the answer choices are a little closer. So, give me a second. Let me get my paper. Get my classroom light to turn back on. I know you can't see That's off, but I love these sensors. Okay, so I'm going to do this in the Desmos to help you all. I'm just pulling out my paper so I can see the numbers. So you can enter it all at the same time. Just make sure you use parentheses if you do. You're going to do mass times percent plus mass times percent plus mass times percent because we have 3 isotopes. So you're going to do 27.98 times 92.2 close parentheses. That's the first isotope, mass times percent, plus the second isotope, parentheses, 28.98 times 4.67. I really hope you can see the calculator on this. Sorry if you can't. Close parentheses, plus open parentheses. The last isotope is 29.97 times the percent, 3.1. Close parentheses. And you can hit enter. Actually, you don't have to hit enter. No. Oh, good. Control Z works. Okay. So I'm going to take that answer. Oh my goodness. And at the very end, divide it all by 100. And we get 28.0799996. And that rounds to 28.08. So you can do all that work, or if the answer choices are nice and not too close to each other, you can just see which one do you see the most of, which one has the biggest percent. Oh, there's the mass for it. Oh, look, that's really close to one of the answer choices. All right, so you guys should be able to do, let's see, based on percent abundance, what is the identity of the unknown substance? Okay, let's see. You need to use your periodic table. And I'm going to focus on the isotope that has the largest percent abundance. And remember, this number means mass. So I'm going to look on my periodic table. I'm going to see which element has a mass of 16 or close to 16. Oh, look, oxygen does. Based on percent abundance was identity. So technetium, because the average atomic mass is close to 99, that's not true. That's the percent. The average atomic mass should be close to 16 because that's the one you see the most of. Vanadium, because 16, 17, 18 add together for a total mass. Nope. C is chlorine because the average of 16, 17, and 18 is 17. No, that's not the type of average we're doing. And if you really want to do the math, you can, or just focus on the one that you see the most of, biggest percent. Oxygen, because isotope with greatest percent abundance is close to its average atomic mass. Yes. Okay, so this is another, let's see, another percent abundance one, but again, you don't have to do the math for it. Please give 12 a try. And if you don't know how to do it, you need to find someone who does. Which of the following explanations best describes how an atom emits color? Guys, that was our whole flame test lab we did, and I know you guys at least got to do that, and if you didn't, hopefully you did the Google form with the videos. So, electrons jump to higher energy levels and specific wavelengths are emitted as the electrons return to ground state. If it's talking about specific wavelengths, that means color. The photon leaves the electron after it gets all excited and goes through de-excitation and emits color. And that's when it falls or returns back to ground state. I match each of the models with a description below. I really hope by now you can do this. And if you can't, I'm sorry. Okay, so each model is showing an atom, and the arrow is showing the direction the electron's going. So, is the electron jumping away from the nucleus or falling back towards it? In A and D, it's jumping away. So it's going through excitation. Can I spell it again? Right, so in both A and D, it's going through excitation. If it goes through excitation, if the arrow is pointing away, it needs to get something to make it excited, meaning it absorbs energy. Absorbs energy. So A and D are both going to have the word absorption. Now, the only difference is this says high and this says low. Low is referring to a shorter jump, a shorter arrow. High is talking about a bigger jump or a bigger arrow. So model A, low energy absorption, did not absorb much. Model D, high energy absorption, absorbed more than model A, right? All right, so because I gave you those two, hopefully you can figure out the other two. Emission is talking about emit energy, energy leaving. All right. Violet light has more energy than red light. Which of the following answer choices describes the movement an electron makes to produce this color of light? All right, so here's the thing. It's talking about energy levels. Draw a little atom. It's like energy level 1 that the electrons live on, energy level 2, energy level 3, energy level 4. That way you have a picture to look at when you're thinking about these energy levels. They're really the orbitals. So violet light has more energy than red light. So violet light is going to be when the electron's falling from a really far space, from like really far away from the nucleus. I would say when an electron falls, like from 4 to 1. Let's see if there's anything like that. Electron jumping from first energy level to fourth energy level. So here's the thing. A lot of you are going to put that. You don't see the color when they jump. You only see the color when they fall. So I already know A and B is wrong. So let's look at C and D, because that's talking about falling. That's when you see the color. That's when an electron goes through de-excitation. It's like getting not excited anymore. An electron falling from fourth energy level to second energy level. Electron falling from fourth energy level to first energy level. So violet light has more energy than red, which are the following answer choices. So it's going to be when it's falling the furthest. Falling all, like I said, I predicted falling all the way from 4 to 1. So 16 says use the information to answer the following question. What is the identity of the unknown element and why is the color emitted? We just talked about that a bunch. You need to look back through Any notes you have on that? If you're not sure what to do with it, please answer question 16. '17, I know some of us can have an issue with this. So line spectra of various elements in a mixture are given in the diagram. What metals are in the mixture based on the spectra? Okay, so, and also your paper might be kind of small, but you can zoom in on Google Classroom. Here's the mixture. I want to line up the lines so those match. That does not match. That matches. So to see what it's made of, I want to find the matching lines. Now there's some left over. So I do know strontium. Wait, let me keep this in color. I do know strontium is definitely in this mixture. But there's something else because I have some lines that I did not match up. So I'm going to draw this till I hit, oh look, lithium. It goes through cadmium and lithium, so let's finish this off. Do you see how there's some extra lines with cadmium? Oh, that even matches. Okay. Oh, I cannot get this. No, I just trashed it all. So because there's extra lines with cadmium, cadmium is not in the mixture, but strontium and lithium are, because they match up perfectly with the lines in the mixture. So lithium, strontium, answer C. And I got plenty of extra practice for that if you need some. Right, label on the diagram below where excitation, de-excitation occurred. Describe what occurs. This should be in your notes. You should have done this at some point. You should definitely be able to see any notes you have on Google Classroom. If you don't have it, it is on the answer sheet in case you guys didn't talk about that. The energy that goes into the electron, remember that's really a little electron, is called a photon. It's light or heat energy going into it, and then that makes it excited. The electron absorbs energy. That's what's happening right here. All right, and you should see the rest. But basically, at the very end, when the electron falls, it releases energy or emits energy. And there's more you can write from the answer key. But when it emits energy, that photon that leaves, that's the color that you see. So it's when it goes through de-excitation. And there are videos on YouTube. Please, 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 if you don't know about this, please search it up on YouTube. Because, I mean, I could talk about it. I feel like you guys are bored at this point. All right, 19. Oh, I was using. Electron X can change to a higher energy level or a lower energy level. Which statement is true of electron X? So electron A says electron X emits energy when it changes to higher energy level. No. Emit does not go with higher, like changes to higher. It absorbs energy when it goes to a higher energy level. And B says electron X absorbs energy when it changes to a higher energy. Oh, look at that. Okay. Guys, if you don't remember about electron movement and spectra and all that, please do the quizzes practice. Hopefully will be on your guys' Google Classroom or somewhere for you to click. And again, search on YouTube. Search on Google. Google Classroom. Look in your notes. Go ask another chemistry teacher if you can have some of their notes. I'm Miss Petrassi. You're welcome to send me an email. If you need help, I can send you some info if you need it. Okay? All right. Good luck studying and good luck on your guys' midterm.